Good morning, children. Myself, Yoganand HC, PGT Chemistry from JNV Bijapur, Karnataka. Children, you are well aware that in the class 11th chemistry syllabus, the ninth unit is about hydrogen. In this unit, you are going to learn about hydrogen and its properties, methods of preparation of hydrogen in the laboratory as well as on large scale. Later on, you are going to learn about water and its properties, methods of softening of hard water, and at the end, you are going to learn about hydrogen peroxide, its structure and properties. But first, let us begin with hydrogen. Children, hydrogen is the first element in the modern periodic table and is the lightest element known. It exists as diatomic molecule and hence it is called dihydrogen. Look at here in the picture, two atoms of hydrogen combine together to form a molecule of hydrogen. The atomicity of hydrogen molecule is found to be 2 and hence it is a diatomic molecule and is called dihydrogen. If you go back to the history of hydrogen, hydrogen was discovered by Henry Cavendish in the year 1766, but the name hydrogen was proposed by Anthony Lavoisier because hydrogen produces water on burning with oxygen. In Greek, hydro means water, gen means producing. Together, hydrogen means water producing. In other words, we can say that hydrogen, when it is burnt with oxygen, we are going to get water. Unique position of hydrogen in the modern periodic table. Hydrogen is the first element in the modern periodic table with atomic number is equal to 1 and electronic configuration as 1s1. Children, the position of hydrogen in the modern periodic table is anomalous because it resembles both alkali metals as well as halogens. Let us find out how does hydrogen resembles alkali metals of group 1 and halogens of group 17 in detail. Resemblance of hydrogen with alkali metals. Electronic configuration. Hydrogen, like any other alkali metals, has one electron in its valence shell. Now look at here, hydrogen with atomic number 1. We can write the electronic configuration as 1s1. Lithium atomic number is equal to 3 and I can write the electronic configuration as 1s2 2s1. In both the cases, you can notice one electron in their valence shell. It shows that hydrogen, like any other alkali metal, has one electron in its valence shell. Second one, electropositive character. Hydrogen, like any other alkali metals, is electropositive in nature because, like any other alkali metal, it has a tendency to lose an electron. By losing an electron, it forms positively charged cation, which is called proton. Look at here, sodium loses one electron, it forms Na plus ion, and hydrogen also loses one electron, it forms H plus ion. By that way, you can say that hydrogen resembles alkali metal in terms of electropositive character. Oxidation state. Like any other alkali metal, hydrogen exhibits +1 oxidation state in its compounds. Let me take up an example. In case of sodium chloride, Na exhibit +1 oxidation state, but in case of hydrogen chloride, you can see hydrogen also exhibit +1 oxidation state, and hence we can say that hydrogen resembles alkali metal in terms of oxidation state in its compounds. Combination with electronegative elements. Like any other alkali metals, hydrogen forms binary compounds with electronegative elements such as halogens, oxygen and sulfur. You can notice here halides, sulfide, oxides formed by the hydrogen on one side and halides, sulfide and oxide formed by the alkali metals on the other side. There is a similarity between them and hence we can say that like alkali metal, hydrogen also forms binary compounds with electronegative elements. So these are the four very important characteristic feature where hydrogen resembles with alkali metals or the group 1 metals in its properties. Let us go for resemblance of hydrogen with halogens. Number one, electronic configuration. Like halogens, hydrogen has only one electron less than its nearest noble gas configuration. Children, look at here. In case of hydrogen, atomic number is equal to 1s1. That means it is shortage of one electron in order to attain the nearest noble gas configuration of helium, that is 1s2. Now look at here, example for the halogen I taken here, fluorine. Fluorine atomic number is equal to 9, and you can see here it is also shortage of one electron in order to attain the nearest noble gas configuration of neon. So in that way, you can say that electronic configuration of hydrogen is similar to that of halogen. Both are in need of one electron to attain the nearest noble gas configuration. Non-metallic character. Like halogens, hydrogen is also non-metallic in nature. Third one, atomicity, nothing but diatomic nature. Hydrogen molecule is diatomic like any other halogen molecules. That means halogen molecules as well as hydrogen are diatomic in nature. That means two atoms of hydrogen combine together to form molecule of hydrogen with atomicity is equal to 2. Fourth one, electronegative character. Hydrogen, like halogens, has tendency to gain or accept an electron to form monovalent anion. Look at here, hydrogen, by accepting one electron, it forms H minus ion. That means hydride ion, similar to that of fluorine, which is halogen, which is also has the tendency to gain one electron to form F minus, so that it attains nearest noble configuration of neon. In that way, we can say that hydrogen resembles with that of halogen in terms of electronegative character, as both of them are ready to accept an electron to attain the noble gas configuration of nearest gas, noble gas rather. Oxidation state. Like halogens, hydrogen exhibit oxidation state of -1 in its compounds. Look at here, in case of sodium hydride, oxidation state of hydrogen is -1, similar to that of sodium chloride, where chlorine exhibit -1 oxidation state. In that way, we can say that oxidation state of halogen and hydrogens are similar in their compounds. Children, after learning about the resemblance of hydrogen with alkali metals and halogens, let us move towards occurrence of hydrogen. Hydrogen is the most abundant element in the universe, which is around 70% of total mass of the universe. Not only that, hydrogen is the third most abundant element on the surface of the earth. A hydrogen is being visualized as the major future source of energy, which you are going to learn under the heading hydrogen economy at the end of this unit. Isotopes of hydrogen. Children, there are three isotopes of hydrogen, namely protium, deuterium, tritium. After these three isotopes, the first two are non-radioactive element, whereas tritium is the only radioactive isotope of hydrogen. Preparation of dihydrogen. Number one, laboratory preparation of dihydrogen. In the laboratory, hydrogen can be prepared by two methods. Number one, when dilute hydrochloric acid is reacted with granulated zinc, you are going to get a zinc chloride along with the release of hydrogen gas. Not only that, when zinc is treated with aqueous alkali like sodium hydroxide, you are going to get sodium zincate along with the release of hydrogen gas. So these are the two common methods which are used in the laboratory for the preparation of hydrogen. Let us move towards commercial production of dihydrogen. Under that, electrolysis of water. Children, hydrogen of highest purity is prepared or manufactured by the electrolysis of water using platinum electrodes in the presence of a small amount of mineral acid like sulfuric acid. Now, why do we add sulfuric acid? Children, in order to increase the conductivity of pure water, we need to add a small amount of dilute sulfuric acid. Now, during electrolysis, water undergo electrolysis to release hydrogen at cathode, whereas oxygen at anode. So these are the best method for the commercial production of dihydrogen. Let us go for the second method, that is electrolysis of brine solution, which is also called chlor-alkali method. In this method, when aqueous brine solution is electrolyzed, we are going to get the three product sodium hydroxide, chlorine and hydrogen. As in this process, hydrogen is produced as a byproduct during the production of a major product called sodium hydroxide. As in this process, both chlorine and sodium hydroxide are produced. This process is also called chloralkali process or the method. Third method, by the reaction of steam on hydrocarbons or coke. Children, the reaction of steam with hydrocarbons like methane at very high temperature in the presence of catalyst like nickel result in the formation of water gas. What is water gas? Please look at here. Water gas is nothing but mixture of carbon monoxide and hydrogen. Look at here. When steam is passed through the methane, you are going to get mixture of carbon monoxide and hydrogen. This mixture is called water gas. Remember, this mixture of carbon monoxide and hydrogen is used for the synthesis of methanol or any other hydrocarbon, and hence water gas is also called syngas, otherwise called synthesis gas. That means you are going to produce some other hydrocarbons using carbon monoxide and hydrogen mixture, and hence water gas is called syngas. Nowadays, syngas is produced by using coal, and that process is called coal gasification. And you can see this is a picture of coal gasification plant in India. After understanding laboratory preparation of hydrogen and commercial production of hydrogen, let us move towards chemical properties of dihydrogen. Remember, dihydrogen is not so very reactive, which is due to high bond dissociation enthalpy around 435.88 kilojoules per mole at 298 Kelvin. Let us understand some of the important chemical properties of dihydrogen. Number one, reaction of dihydrogen with halogens. Children, dihydrogen react with halogens in the presence of sunlight to give respective hydrogen halides. Let me take up one particular example where hydrogen combines with chlorine in the presence of sunlight to give hydrogen chloride gas. Remember, this reaction is possible only in the presence of sunlight. In the dark or in the absence of sunlight, the reaction does not take place. But in the case of fluorine, fluorine combines with hydrogen even in dark also. With iodine, it may require a catalyst. Second chemical property, a reaction of dihydrogen with a dioxygen. Children, hydrogen combines with oxygen to form water. But this reaction is highly exothermic in nature, where delta H is equal to minus 285.9 kilojoules per mole. The third chemical property is reaction of hydrogen with nitrogen. This is nothing but manufacture of ammonia by Haber's process. Remember, hydrogen react with nitrogen at 673 Kelvin and 200 atmospheric pressure in the presence of iron as catalyst and molybdenum as promoter forms ammonia. Children, remember this reaction is also exothermic in nature and delta H naught is equal to minus 92.6 kilojoules per mole. Fourth chemical property is reaction of hydrogen with metals. Hydrogen react with reactive metals like sodium, potassium, calcium, lithium at very high temperature around 500 Kelvin to form respective hydrides. Children, we are going to discuss about hydrides in detail in the coming classes. Look at here, sodium combines with hydrogen to form sodium hydride, whereas calcium combines with hydrogen to form calcium hydride, which is also called hydrolith. The fifth important chemical properties of hydrogen is reaction of hydrogen with metal oxides and metal ions. Remember, hydrogen acts as a strong reducing agent and therefore reduces metal oxide into respective metals. In this case, copper oxide is reduced by hydrogen to respective copper, whereas hydrogen itself undergo oxidation to form water. Sixth chemical property is reaction of hydrogen with organic compounds. Children, hydrogen react with many organic compounds in the presence of catalyst to give useful hydrogenated product of commercial importance. One of that is hydrogenation of oils. Children, vegetable oils are polyunsaturated in nature, in which a large number of carbon-carbon double bonds are there. The carbon-carbon double bonds present in the vegetable oils can easily undergo oxidation and the oil become rancid. Nothing but oil become unpleasant in smell as well as taste. Hydrogenation reduces number of double bonds and thereby reduces the chances of rancidity. Children, during hydrogenation, vegetable oils when treated with nickel as catalyst in the presence of hydrogen result in the formation of vegetable ghee, which is nothing but saturated in nature. And the vegetable ghee can also be called as margarine or vanaspati or ghee. Second part of this is hydroformylation of olefins to aldehyde. Children, olefins are the group of unsaturated open chain hydrocarbons possessing one or more double bonds, the simplest of which is ethylene. Children, olefins react with carbon monoxide and hydrogen in the presence of octacarbonyl dicobalt as a catalyst under high pressure and temperature to form aldehydes. This process of formation of aldehydes is called hydroformylation, otherwise called oxo process, wherein aldehydes can be further reduced to alcohols in the presence of nickel as catalyst by treating with hydrogen, and this is what hydroformylation of olefins to aldehydes and alcohols. Children, there ends the important chemical properties of hydrogen. Let us go for the next topic, that is